So hello friends, I'm here. I'm here to talk. I'm here to give a presentation on the topic digital logic family. As you can see, semiconductor devices and PLDs. So I'm giving credits to my group for creating this PPT and making its animations, and even and the great credits go to Professor Swati Mirlekar. So objectives and outcomes. So before we start about the analysis on the topic, it is important to know about the objectives and outcomes to get basic knowledge about digital logic families, to know the types of semiconductor memories and PLDs, programmable logic devices, so one can understand and apply for real-time purpose. A bit of history. The first transistors were fabricated in 1947 at Bell Laboratories, Bell Labs, by Brattain with Bardian providing the theoretical background, and Shockley managed the activity. So the trio received Nobel Prize in Physics for their work in 1956. And the transistor that they developed was a point contact transistor and was a type of bipolar junction transistor, BJT. Integrated circuits. Integrated circuits are the chips pieces of semiconductor material that contain all the transistor resistors and capacitors necessary to create a digital circuit or system. So this slide shows about some important characteristics of digital ICs: fan out, power dissipation, propagation delay, noise margin, fan in, operation temperature, power supply requirements. So the logical diagram shows about fan out. So fan out specifies the number of standard loads that the output of the gate can drive without impairment of its normal operation. Power dissipation is measure of power consumed by gate when fully driven by all its inputs. Propagation delay is the average transition delay time for the signal to propagate from input to output when signals change in value. It is expressed in ns. Noise margin. It is the maximum noise voltage added to an input signal of a digital circuit that does not cause an undesirable change in the circuit output. It is expressed in volts. Fan in is the number of inputs connected to the gate without any degradation in the voltage level. For the logical diagram. Operating temperature. All the gates or semiconductor devices are the temperature sensitive in nature. The temperature in which the IC is effective is called as operating temperature. Operating temperature of IC vary from 00 Celsius to 700 C. So this slide gives some information about logic families. So logic families are sets of chips that may implement different logical functions but use the same type of transistor and voltage levels for logical levels and for the power supplies. These families vary by speed, power consumption, cost, voltage and current levels. So IC digital logic family: diode logic, diode transistor logic, resistor transistor logic, emitter coupled logic, metal oxide semiconductor, complementary metal oxide semiconductor. The most commonly used is complementary metal oxide semiconductor. So the following features shown for different types of logical families are: for transistor logic, it's NAND gate; for ECL, it's OR/NOR gate; for CMOS, it's NAND and NOR gate. So for fan-in property, TTL is 12 to 14, ECL is greater than 10, CMOS is greater than 10. Power dissipation, for fan out, it's some like same parameters. Power dissipation 10, 175, 0.001 for TTL, ECL and CMOS respectively. So propagation delay 10 for TTL, less than 3, that is it's the lowest propagation delay, that is for ECL, and 15 highest for CMOS. Noise immunity very good, excellent respectively for TTL, ECL and CMOS. So coming to semiconductor memories, where we need to understand the basic concepts before we can start about memory. So memory basic concepts are: stores large number of bits m into n, that is to m words of n bits each, k equal to log to address input signals, or m equal to 2 power k words. Example 40, suppose it is given as 4096 into 8 memory, so 32,768 bits. It needs 12 address input signals, 8 input output data signals. Memory access, read write, enable, multiport. So this is the branching for the semiconductor memories, RAM and ROM, that is read write memory, or even called as random access memory, and ROM means read only memory. So RAM is further divided into dynamic RAM and static RAM. So dynamic RAM is DRAM, static RAM short form is SRAM. So read only memory, that is ROM, is has four properties: mask, fuse ROM, programmable ROM, that is PROM, erasable ROM, EPROM, electrically erasable ROM, double double EPROM, and flash memory, ferroelectric RAM, that is FRAM. Random access memory. So typically a random access memory is typical volatile memory. Bits are not held without power supply. Read and write too easily by microprocessor during execution. Internal structure more complex than ROM. A word consists of several memory cells, each storing one bit. When row is enabled by decoder, each cell has logic that stores input data. When read write indicates write, or outputs stored bit when read write indicates read. So basic types of RAM. So there are basically two types of RAMs. One is SRAM, we call it as static RAM. DRAM, we call it as dynamic RAM. So static RAM, so memory cell uses flip-flop to store bits. Requires 6 transistors, hold data as long as power supplied. So DRAM, it is more compact than SRAM, retains data for only 2 to 4 ms, and uses MOS transistor, that is metal oxide semiconductor transistor. So on the right side it shows the diagram for SRAM and DRAM. Refer to it. RAM variation: PSRAM, pseudo static RAM, DRAM with built-in memory refresh controller, popular low-cost high-density alternative to SRAM. NVRAM, non-volatile RAM, holds data after external power removed. Battery-backed RAM. SRAM with own permanently connected battery, writes as fast as reads. No limit on number of writes, unlike non-volatile ROM based memory. So this diagram shows about RAM. So this is the pin diagram. In the second pin diagram, in the first pin diagram, data input, addresses CS, read write data output, and in the second pin diagram, 3:8 is given. So inputs are A0, A1, A2, and for the data outputs are connected to each RAM in the cell. So the memory is given. So ROM is read only memory, so it is non-volatile and can be read from both but not written to. So its uses are: store software program for general purpose processor, store constant data needed by the system, implement combinational circuits. PROM, programmable read only memory. Programmable read only memory PROM, or one time programmable ROM OTP, can be written to or programmed. Typically these devices uses high voltage to permanently destroy or create internal links within the chip. Consequently, a PROM can only be programmed once. So EPROM, its full form is erasable programmable read only memory. So can be erased by exposure to strong ultraviolet light, typically for 10 minutes or longer. EPROM chip packages can often be identified by the prominent quartz window, which allows UV light to enter. Some EPROM chips are factory erased before they are packaged and include no window. So these pictures show about some sample EPROM components. So double EPROM, so air ROM and flash memory. So writing is a very slow process and needs higher voltage than the one used when accessing data. So modern flashes are fabricated now with a capacity as high as 32 GB as of 2007. This feature, along with its endurance and physical durability, has allowed the newest flashes to replace magnetic in some applications, such as USB flash drives. So flash memory is sometimes called as flash ROM or flash EPROM. when used as a replacement for older ROM types. Features of EPROM are shown. Serial memory interface, typically EPROM or flash memory, compact package, low cost, low access, and a convenient program storage. PLD. PLD full form is programmable logical device, an IC that contains large number of gates, flip-flops and registers that are interconnected on the chip, can be configured by the user to perform a logic function. Many of the connections are fusible links that can be broken. The following slide shows some basic ideas of PLD. Refer to that. The AND inputs are called as product lines. Each product lines is connecting to one of the inputs of each OR gate. Three fundamental types of standard PLDs: PROM, PAL and PLA. So problems of using standard ICs in logic device require hundreds or thousands of these ICs, require a considerable amount of circuit board space, require a great deal of time and cost in inserting, soldering and testing, required to keep a significant inventory of ICs. So advantages of using PLDs: less board space, fewer printed circuit boards, smaller enclosures, lower power requirements, small power supplies, availability of design software. So the following logical diagram shows about internal structures of PLD. Basic idea: types of PLD: SPLD, CPLD and FPGA. Simple programmable logic devices, complex programmable logic devices, and field programmable gate array. The least complex form of PLDs can typically replace several fixed function SSI or MSI, that is small scale integration or multiple scale integration devices and their connections. So a typical package has 24 to 28 pins. So PAL, GAL, PLA, PROM. PAL is programmable array logic, GAL is generic array logic, programmable logic array, programmable read-only memory. Much higher capacity than CPLDs are made using 22664 SPLDs, 84 pin PLCC package, 128 pin. These are the two types. FPGA is different from SPLD and CPLD. Two basic classes of FPGA are coarse grained and fine grained. So common licensed video. Thank you friends. Thank you friends for listening to me, and I give full credits to my group and our professor Swati Mirlekar.